Hey everyone! In this video, I'm going to show you how to do a correlation test from section 4.1 of our textbook. So first I've opened up our textbook. This is the HTML version of our book, so it looks a little different than you might think from your version that you read. It's on page 188, and it talks about an example 4 if there's a linear relationship between two columns of data. So I'm going to run you through this hypothesis test and then show you the correlation tables that you'll need to reference, and then I'll also give you an example. Follow one of the examples in the book. So in section 4.1 about scatter diagrams and correlation, you're told to compute correlations between two columns of data. So two variables that are related somehow, or at least we think that they're related, and we want to come up with a numerical expression for how strongly and in which direction the data are relating to each other. So to go through this test, we have to follow a couple of steps. First, we have to find a linear correlation. Then we need to look for a critical value from a table. And then we just compare two numbers and come up with an answer. So the caution here is that even though there is a correlation or a number that is between two columns of data, it doesn't mean that one variable caused the other one to make a change. So it could be just happenstance that as one variable increased, so did the other one. So there's kind of the classic example of ice cream sales and number of shark bites through the year. As ice cream sales increase through the summer, so do the number of shark bites. But there are some other variables at work there, like the weather happens to be nicer, and there's not a direct causation between the two variables. You need to look at other lurking variables out there. So that aside, we're going to look at example 5. And I've taken this data, number of colas per week and the bone mineral density from the example, and I've brought it into Google Sheets here. So I've just copied and pasted the data. That's why I use this HTML version. I can copy the data easily. I copied and pasted the data into Google Sheets. Now I need to compute the correlation. So I'll use the function equals, CORREL, open parenthesis, so coral for correlation. Then I just have to highlight my first column of data, x's or y's, it doesn't matter because the correlation will be the same no matter if you look at x first then y or y then x first. And then type a comma and then highlight your other column of data. Notice that I didn't highlight the title of my column. Close parenthesis, push enter. So there is a correlation, as in there's a number that's going to describe the strength and direction of this linear relationship. And actually, maybe we should check to see if there is a linear relationship. So I'm going to do a little sidetrack right here. I'm going to highlight my two columns of data, and I'm going to go over here to insert chart. And Excel or Google Sheets thinks it knows what it wants to graph, but I'm going to change the chart type to a scatter plot down here. Okay, this kind of looks good. I do think the data looks kind of squished up here, so maybe I might want to change that. But I could change that later on. I do tend to see a linear relationship. It looks kind of flat, but it looks like it's there. Let's see about editing this chart. Vertical axis. Let's go from 0.75 up to, oh, that's even looking better. Let's try 0.8 actually. Little trial and error here. 0.8. Oh, that's looking even better. So it looks a little wobbly, this relationship, but at least it looks kind of linear. If this was drastically not linear, I would need to go in a different direction and not even use a correlation. But this looks okay enough for me to continue. So that was just a quick check just to make sure that I said the data looked linear, but now I actually looked at it and I believe it. So now this linear relationship, how strong or how tight are these points to an imaginary line going through the data? The strength is given by the number 0.8, and it's close to a 1, a -1. So that's a pretty strong relationship versus being closer to 0. And then the negative is there saying that the direction is negative. So the data start in the upper left and then go down to the lower right. So is this a significant relationship? It seems pretty strong, and the direction's negative. So the strength sounds good. It seems like the number of colas per week might actually influence your bone mineral density. The way we can test to see if there is a significant relationship is to look at a critical value. So I have opened up Appendix A. So if you go to your table of contents in your book and go to Appendix A and then start sorting through the tables, it looks like it is page A2. There is a column for your sample size, that's N, and then there's a list of correlation coefficients. So when we look at our sample size, I can go back here and say, okay, we started in spot number 3 and went up to spot 17, so that's 15 data points. So N is 15, so I go down to the row 15 and I look over, and there's a correlation coefficient of 0.514. So what that means is this is the minimum strength that your data would need to have in order to have a significant relationship. So what we mean by significant is you can look at a scatter plot and be like, oh, that kind of looks good. Seems like it's strong, but actually there's a cutoff mathematically for what we consider to be a significant relationship. So it's not just okay, but it's even better. So our minimum cutoff, going back to this table, we had 15 pairs of data. So it's not 30 because there's 30 numbers. It's 15 because there's 15 pairs of data. The minimum cutoff is 0.514. So as long as our correlation from our data is bigger than 0.514, we're good and we have a significant relationship. So our correlation was -0.8. So ignore the negative because we only want to focus on the strength. Our strength is 0.806, which is definitely bigger than that 0.514. So yes, there is a significant relationship between number of colas per week and bone mineral density. Now we still haven't proved that colas have an effect on bone mineral density unless we've done an experiment and actually set up had a treatment group and a placebo group to make that comparison. But suppose we had done that and then gathered our data, it looks like there is a significant relationship here. So going back to our textbook to show you what we did, we had our data set, we computed the correlation of the data, we looked up the critical value of our data, and then because our correlation, when we only look at the positive number, drop the negative, as long as it's bigger than our critical value, we have a negative association existing between our two variables.